Neutron stars, a city-sized stellar object with a mass of about 1.4 times that of the Sun. A teaspoon of neutron star material would weigh about 10 million tons, and if you went inside one, you'd certainly die. Let's discuss one of the most extreme things in the universe, neutron stars, in today's video of Discover Zen. Neutron stars are formed when a massive star runs out of fuel and collapses. The very central region of the star, the core, collapses, crushing together every proton and electron into a neutron. Once formed, they no longer actively generate heat and cool over time. If the core of the collapsing star is between about 1 and 3 solar masses, these newly created neutrons can stop the collapse, leaving behind a neutron star. Stars with higher masses will continue to collapse into stellar mass black holes. This collapse leaves behind the densest object known, an object with the mass of a sun squished down to the size of a city. These stellar remnants measure about 20 kilometers or 12.5 miles across. One sugar cube of neutron star material would weigh about 1 trillion kilograms, or a billion tons on Earth, about as much as a mountain. Since neutron stars began their existence as stars, they're found scattered throughout the galaxy in the same places where we'd find normal stars. And like stars, they can be found by themselves or in binary systems with a companion. It's estimated around 1 billion neutron stars are present in the Milky Way galaxy. Many neutron stars are likely undetectable because they simply do not emit enough radiation. However, under certain conditions, they can be easily observed. A handful of neutron stars have been sitting at the centers of supernova remnants quietly emitting X-rays. More often though, neutron stars are found spinning wildly with extreme magnetic fields as pulsars or magnetars. In binary systems, some neutron stars can be found accreting material from their companions, emitting electromagnetic radiation powered by the gravitational energy of the accreting material. Neutron stars that can be observed are very hot and typically have a surface temperature of around 600,000 Kelvin. Their magnetic fields are between 10 to the 4th power to 10 to the 11th power Tesla, which is around 10 to the 8th power and 10 to the 15th power, 100 million to 1 quadrillion times stronger than Earth's magnetic field. The gravitational field at the neutron star's surface is about 2 times 10 to the 11th power, 200 billion times that of Earth's gravitational field. As the star's core collapses, its rotation rate increases as a result of the conservation of angular momentum, and newly formed neutron stars hence rotate at up to several hundred times per second. Some neutron stars emit beams of electromagnetic radiation that make them detectable as pulsars. The radiation from pulsars is thought to be primarily emitted from regions near their magnetic poles. If the magnetic poles do not coincide with the rotational axis of the neutron star, the emission beam will sweep the sky, and when seen from a distance, if the observer is somewhere in the path of the beam, it will appear as pulses of radiation coming from a fixed point in space, the so-called lighthouse effect. The fastest spinning neutron star known is PSR J17482446 AD, rotating at a rate of 716 times a second, or 43,000 revolutions per minute, giving a linear speed at the surface on the order of 0.24 c, that is, nearly a quarter of the speed of light. So, we know neutron stars are one of the most extreme things to exist in the universe. Now let's think of another powerful object. What are magnetars? Well, that sounds like a different topic to discuss on Discover Zen.